From the earliest times, we seem to have believed that the vast oceans, with all their natural resources, would never let us down. The oceans seem to be unchanging, immune to anything that we might do. But human activities have changed this. As with all other resources, the oceans are limited. Today, the Arctic is where we are observing strong evidence of ongoing climate change, and a new consequence of this has been identified strongly here: ocean acidification.
Ocean acidification is real. It's happening at an accelerating rate. It's happening at least 5 times and probably 10 times faster than it's ever happened in the history of the planet.
This is a new challenge for the animals that live in the water. They're now challenged with a higher concentration of carbon dioxide.
Once CO2 enters the ocean, the legacy of acidification will last for thousands of years.
Arctic peoples are experiencing the ongoing changes at first hand. The Arctic communities are extremely worried about the effects on our ecosystems because we so deeply rely on the Arctic Ocean and its animals.
The Arctic is highly vulnerable to climate change. Already now, the Arctic oceans are warming. The summer and winter ice cover is shrinking, and enormous quantities of fresh water from rivers and melting ice are pooling at the ocean surface. The very basis of the system is changing.
We traditionally have viewed many of the changes that are and could happen to the Arctic as stresses on marine ecosystems, on geochemical systems. Traditionally, these have been warming, freshening, changes in nutrient supply. But now we have what can be considered the new kid on the block, ocean acidification.
As humans continue to burn coal, oil and gas, we are changing the composition of the atmosphere. The amount of CO2 in the atmosphere and in the surface ocean used to be in balance. But this is no longer so. The natural balance has been overturned. The result is a massive increase in CO2 absorbed at the ocean surface. And this is driving chemical changes that are affecting all aspects of marine life.
This is the first time that as humans we are actually changing the whole planet. We are actually acidifying the whole ocean today, and the present projection tells us that within a few decades, or by the end of this century, the ocean will be 2 times more acidic than it is today. And we also know that in the Arctic it might be even faster. The question, of course, is what will be the consequences of these chemical changes for species, ecosystem, and all the services that they are providing.
The ocean has been performing a huge climate service over the last 200 years by having great capacity to absorb CO2. It's taken up 50% of the carbon dioxide that we have emitted and is currently still taking up 25% of the carbon dioxide that we are producing today.
The CO2 that has already been put into the air and the CO2 we will put into the air in coming decades is causing ocean acidification to become a global problem. And the latest research indicates that regions of the Arctic oceans will be the first to reach geochemical thresholds of ocean acidification. Cold polar waters absorb more CO2 than the warmer waters further south, and the disappearing sea ice is opening up even more of the ocean surface to the air. On top of this, due to the general warming, increasing amounts of fresh water are running into the ocean. Together, these are changing ocean conditions faster than at any time in the last 55 million years.
The Arctic food web, it's what we call a kind of a truncated food web. It's a short, simple food web compared to food webs with much higher biodiversity, for example, in the tropics. And the organisms, some of the organisms are already challenged with other aspects that are related to the Arctic environment, like cold temperatures. So this is why it's thought that this additional stressor that we're calling ocean acidification, the effects of that may appear first in Arctic ecosystems.
Over the past 40 years, a large number of international expeditions have been conducted in the Arctic Ocean. Widespread changes in water chemistry have been observed, and samples of fish, crustaceans and plankton have been taken to investigate changes in ocean life.
They're somewhere in the region of about 90% of all the animals that you find out there. I mean, when we think about marine biology, most of us maybe think of whales and fish and that kind of stuff. But in actual fact, snails and worms and sea urchins and sea stars and mussels, all those kinds of things are the great majority of what there is out there. So most of the animal production in the ocean is these kinds of organisms.
One example of potential species extinction is this species. So this is a brittle star, a close cousin of the sea urchin. And if you expose eggs and larvae of this species to conditions regarding ocean acidification that you can expect within a few decades, they all die within days. And you may not care if this species disappear, but then other species that are feeding on them might disappear too, and that includes fish that we are eating. And scientists are really concerned about the Arctic because similar effect can happen there. And theropods are one of the really good examples showing that keystone species might disappear in the Arctic too within a few decades.
These small marine creatures are vital indicators of what is happening. Some forms of calcium carbonate will become geochemically unstable in the next decades. Pteropods, including the magnificent sea butterfly, find it increasingly difficult to build their protective shell that secures their survival as acidification increases. And these iconic animals are not alone. The effects of the changing living conditions extend to the very base of the food chain. The plankton and zooplankton at the lowest end of the food web are some of the most plentiful creatures in the sea. They are also exposed to acidification. They serve as food for an enormous range of ocean animals, from fish larvae and up the food chains to bigger fish, seabirds and marine mammals. And when the chemical balance under which these microscopic creatures have existed for 10,000s of years suddenly changes, they are at risk of becoming the first component of the Arctic food web that will be affected. If they are threatened, then everything is threatened, including the fish stocks that so many of us rely on for food and a living.
We often see that you can only push organisms so far. So you push them to the limit, and then their reaction is just to crash. So it's instead of seeing a kind of a gradual decline in their performance or in their ability to cope with changes, you see that they kind of just fall off the edge at a certain point. And that's what people refer to as thresholds or tipping points. And there's no doubt that some organismal groups will reach that point at some time in the future, those that are most susceptible to the effects of ocean acidification.
We already know that these ocean changes could have enormous consequences for people living and working in the Arctic, and we have only seen the first signs of change.
With Arctic acidification, there are three major themes. Those are the chemical changes, those where the ocean chemistry responds to the increasing CO2. Then you have the biological responses to those chemical changes. And then finally, the economic, the socio-economic, the fisheries, the social consequences of ocean acidification that actually follow the first two themes.
We are now entering a new era where the consequences of the present acidification will be felt, and where Arctic people and their communities may have to begin to find strategies to adapt.
Changes in the ocean will impact the way of life in the Arctic in a number of ways. Number one, through the economy. If there's less fish, then people who catch fish in the Arctic will be affected, and the industry that depend on this will be affected. There will be impacts on the culture, because Arctic people are really very tied to the environment for various reasons, and so the animals will be impacted, and therefore that will affect the cultural. You also have impacts through tourism and recreational activities. More and more people are coming from around the world to see creatures of the ocean in the Arctic. So you have various effects on the way of life of the Arctic people.
So we know that changes are coming and that these will have consequences for the marine ecosystems, the fisheries, culture, and the economy. But what can be done to prevent even greater impacts from Arctic ocean acidification?
We need to explore all the solutions, including local solutions, and this means working on all the other pressure that we are putting on the ecosystem, including pollution and overfishing. All these are weakening the ecosystem, making them more sensitive to ocean acidification. So what we have to do, really, is to learn how to cooperate with the ecosystem, make them stronger, more resilient to ocean acidification, rather than pushing ecosystem to their limit and beyond. Because if we do that, we will have to face consequences and then adapt to all these changes. So we know that we have to act as quickly as we can, otherwise we will see consequences that we don't want to face.
Indigenous peoples are knowledge holders which offer a wealth of observations. Our wish is to help scientists fill in the knowledge gaps to better understand the effects of ocean acidification. We cannot wait until the system has crashed before we see any political action. We are asking for sustainable and effective solutions now.
If we continue to push the balance, then we will see consequences.
And the effects that we see out there already will become irreversible, and we will change the ecosystem.
Our sensitive environment might be the first to react, so maybe the rest of the world should observe and learn from these lessons.